Good morning everyone. In this video we are going to study electrochemical energy system. Okay. In this particular concept we are going to study some electrodes. Okay. First we'll start with the electrode. So electrode is nothing but, as in the previous class we have studied, that it gives electric contact to make a contact with the non-metallic part of the circuit. Okay, and some types of the electrodes are metal ion electrode, metal salt ion electrode, third one is gas electrode, fourth amalgam electrode, fifth oxidation reduction electrode, sixth ion selective electrode, and seventh one is reference electrode. So these are the some types of the electrodes. Okay, here we'll study definitions of these electrodes. So first one is metal ion electrode. So the title itself, it is telling that your metal is in contact with metal ion electrode. That means as your metal is acting as an electrode, in this case that electrode is in contact with the solution of its own ion. So your definition goes as the electrode in which it is in contact with its ionic solution. So if you are taking Zn as an example, Zn should in contact with ZnSO4 solution. That's what your metal Zn is in contact with ZnSO4, and that can be represented as Zn2 plus bar Zn, or you can write Zn bar Zn2 plus. And one more example here, that is Ag. So if you are taking silver as an example, silver is in contact with silver nitrate. Okay, AgNO3. So that is the example for metal ion electrode. Now come to second one. Second one is gas electrode. So here that again title itself, it is telling that your electrode is in contact with some gas. Okay. So definition goes as electrode in which gas is in contact with an inert metal which is dipped in the ionic solution of gas. Okay, here electrode is in contact with ionic solution of gas. The example you can take, that is a hydrogen electrode. Okay, so this is the second type of electrode. Third one is metal insoluble salt electrode. So here the again title, it is telling that metal is in contact with metal insoluble salt. Means here you are having the solution of sparingly soluble salt, means it is a partially soluble salt. Okay, that salt is not completely dissolving in the solvent system. So that is called sparingly soluble salt. So the definition goes as the electrode in which metal is in contact with sparingly soluble salt of some metal. So here sparingly soluble salt means it has a lower solubility in the solvent. Okay, example you can take as a calomel electrode and silver chloride electrode, or AgCl electrode. About this calomel electrode we'll study in detail in the next video. Okay, that is the example for metal insoluble salt electrode. Now come to fourth one, ion selective electrode. So here in this ion selective electrode, here the ions is in contact with membrane. Okay, the electrode in which a membrane is in contact with ionic solution, or even you may give one more definition, that is here in the this electrode, these ions are specific. Okay, these are going to exchange some ions from other solutions. Okay, that is a ion selective electrode. For example, glass electrode. When you come to the glass electrode concept, that time we'll understand it in depth. Okay, that is a ion selective electrode. Example is glass electrode. Now come to the reference electrode. So reference electrode means, as the title it is telling that reference. Okay, reference means some you can tell that is a fixed one. Okay, here the electrode of fixed potential or standard potential with reference to which the potential of any other electrode can be measured is called as reference electrode. Means here you are going to keep one electrode as a reference whose value is fixed, okay, and you are going to find the potential of other electrode. As you know, in electrochemical cell you are having anode and cathode, two electrodes are there, right? So in that, if anode is something fixed value, like you take 0, okay, 0 as a potential of that particular anode, and you can find out the potential of cathode, that is what the reference electrode. If you are keeping that electrode as a fixed, then it is called as reference electrode, okay. The electrode of fixed potential or the standard potential, and with reference to that you are going to find the electrode of other, the potential of other electrode, that is called as reference electrode. Now the types of reference electrode, that is primary and secondary, okay. As you know, the reference electrode means you have a fixed value, fixed electrode potential value or stable value, okay. In that again we have divided in primary and secondary. So primary reference electrode means here the electrode whose potential is arbitrarily taken as 0, means if your potential of that particular electrode is 0, then that electrode is called as primary reference electrode, and example for that is standard hydrogen electrode. So this already you have studied in your PUC classes, okay. Standard hydrogen electrode, there you have potential as a 0, okay. So here you have hydrogen, in the standard hydrogen electrode what happens, you have hydrogen gas, okay. So due to presence of that unstable hydrogen, you are facing some limitations of using this primary reference electrode, okay. Now we'll have a look on the limitations of primary reference electrode. The first one is, it is difficult to maintain H plus ion concentration as 1 molar. Okay, as you know, this H plus, the hydrogen ion, is highly unstable and it is very difficult to maintain its concentration as 1 molar. The first one. Second one is, it is difficult to maintain hydrogen gas at 1 atmospheric pressure at the interface of platinum electrode. So here, as you know, hydrogen gas is, it is completely pure and dry. That's what it is really very difficult to maintain at a 1 atmospheric pressure in presence of that platinum electrode. The third one is, impurities present in hydrogen gas may poison the platinum electrode, which alters the potential value, okay. If you are taking hydrogen gas, so in that gas you may have impurities sometimes, okay. That impurities act as a poison and that will alter the potential value in the electrochemical system, okay. That's what, that impurities whatever are present in the hydrogen gas, no, sometimes they may react with platinum electrode and it changes the values of EMF. So this is one of the drawback of using primary reference electrode. So next one is, it cannot be used in the pressure of oxidizing agent, okay. If you use oxidizing agent, what happens, a hydrogen undergoes reduction. So in presence of oxidizing agent you cannot use the hydrogen, this electrode, standard hydrogen electrode. And now secondary reference electrode. So here we have divided the reference electrode as a primary and secondary, and as you know, the reference electrodes are having fixed value. So if primary is having 0, means the secondary is having the value other than 0, any value other than 0, okay. So secondary reference electrode are defined as these are whose potential with respect to SHE are known or fixed or other than 0 value, okay. And these are commonly used for the determination of the electrode potential of other electrode, as I earlier mentioned, okay. Here in the secondary reference electrode you are going to have some fixed value of potential, not 0, other than 0 you can have any value. So that is the secondary reference electrode. Example for that is calomel electrode and silver chloride electrode. Those are the example for secondary reference electrode. And this reference electrode also can be defined as, it is a standard electrode which is obtained by dipping platinum foil in 1 molar HCl solution through which hydrogen gas is passed at 298 Kelvin under 760 millimeter pressure. Its electrode potential is taken as 0. Okay, so this is with a certain conditions, at certain standard conditions, that is temperature you should maintain, that is 298 Kelvin, and the pressure is 760 mm, and your potential that time it should be 0, and the concentration of HCl is maintained, that is 1 molar solution. Okay, this is the definition of reference electrode. This is about the electrode types and the reference electrode and types of the reference electrode. Thank you.